Moving on in chapter 2, section 2, solving inequalities using addition or subtraction. If you understood solving equations pretty well, this should hopefully come pretty easy to you because we're doing exactly the same thing. It's just with inequalities now instead of equations. So 2.2, solving inequalities using addition or subtraction. If we're using addition and subtraction today, what do you think we'll use tomorrow? Multiplication and division. You don't necessarily have to write this down. This is just some opening information. Just as you use the properties of equality to produce equivalent equations, you can use the properties of inequality to produce equivalent inequalities. Equivalent inequalities are inequalities that have these same solutions. We're still using the same properties, using inverse operations to move stuff around from one side of the inequality to the other. So it's pretty much just like solving equations. Once again, you don't have to write this down. This is just telling you adding the same number to each side of an inequality produces an equivalent inequality. Just like on equations, if we added the same number to both sides, we got an equivalent equation. You guys remember that? So, they give you an example here. If I have negative 3 is less than 2, that's a true statement, correct? First off. If I add 4 to both sides, that's me adding the same number. Negative 3 plus 4 gives me 1. 2 plus 4 gives me 6. Is 1 still less than 6? Is that still true? Yes. So, that's always going to be the case. Negative 3 is greater than or equal to negative 10. That is true. Adding 3 to both sides, we get 0 is greater than or equal to negative 7. That is still true. So, if I add the same number to both sides of an inequality, it's still going to produce a true inequality. Any questions on how we're solving inequalities today? Let's jump into some examples here. Solve x minus 6 is greater than or equal to negative 10. Graph the solution. If it tells you to graph, I do want you to graph. Solve x minus 6 is greater than or equal to negative 10. So when we're solving inequalities, our goal is still the same. We still want to get the variable isolated by itself on one side of the inequality. So can someone raise your hand and tell me how I would get x by itself in this case? Can someone raise your hand and tell me how I would get x by itself in this case if we're doing it just like we did our equations? Someone raise your hand. If I have x minus 6, it's greater than or equal to negative 10. Yep. Yep. 6 is being subtracted from x. What's the inverse of subtraction? Addition. So I'm going to add 6. To keep it an equivalent inequality, whatever I do to one side, I have to do to the other. What's negative 10 plus 6? Negative 4. Is x now by itself? Yes. Here's my solution. X is greater than or equal to negative 4. So what this means is any number that is bigger than or equal to negative 4 is going to be a solution to my inequality here. Does that make sense? Now we need to graph it. How many numbers do I want you to have on your number line? At least 5. Okay, we did graphing last week. Can someone raise your hand and help me graph this? Yes. Why is it a closed circle on negative 4? Yep, there's a line underneath my inequality symbol, meaning negative 4 is a part of my solution set. I am including negative 4 in that solution. Go ahead and continue. Yeah, I'm going to shade to the right because my solution is any number that's larger than or equal to negative 4. So numbers that are bigger than negative 4 are to the right of negative 4. So I'm shading to the right. And there's the graph of my solution. Any questions on example 1, how we solve for x? Once again, you're just using your inverse operations like we did with solving equations. We good with that? Can I move on? 3 more examples real quick. First one, b minus 2 is greater than negative 9. b minus 2 is greater than negative 9. Someone raise your hand and tell me how to get b by itself here. Someone who hasn't answered yet. I've had the same person answering every time today. I appreciate that.
Did you add 2?
Yes, I'm going to add 2 to both sides. 2 is being subtracted from b. I've got to add 2 to get rid of it. Once again, anything I do to one side, I've got to do to the other to produce an equivalent inequality. Negative 9 plus 2, negative 7. b is now by itself. There's my solution. Open or closed circle on negative 7? Open. There's no line underneath my inequality symbol. So what does that mean for negative 7? Is negative 7 a part of my solution set or no? What? It is not. That open circle, that us not having that line underneath our symbol, means that negative 7 cannot be included in the solution set. If it's b is greater than negative 7, which way am I shading?
Left.
Not to the left. Right, I want all values greater than negative 7. So that would be to the right of negative 7. Remember, if your variable is on the left of the inequality, you can always just shade whichever way the arrow is pointing. The variable must be on the left if you do that, though. Questions on 1? Okay, number 2, what's my step to get m by itself? M minus 3 is less than or equal to 5. How do I get m by itself here? Add 3 to both sides. I get m is less than or equal to, what's 5 plus 3? 8. M is now by itself. Here's my solution. Are we getting the hang of it? Like I said, it's just like solving equations, right? Using those inverse operations. Whatever we do to one side, we've got to do to the other as well. All right, open or closed circle on 8. Closed. It's got that line under it. 8 is included in my solution set. If m is less than or equal to 8, would that be to the left of 8 or to the right of 8? Which way? To the left. Very good. Numbers that are less than 8 are to the left of 8. Questions on 2? How are we feeling about this so far? Good? Everyone feeling good? Just some people? Hopefully everyone. Number 3. 1/4 is greater than y minus 1/4. 1/4 is greater than y minus 1/4. How would I get y by itself in this case? Yeah. 1/4 is being subtracted from y. So I've got to add 1/4 to cancel it out. Whatever I do to one side, I've got to do to the other. What's 1/4 plus 1/4? 1/2. Y is now by itself. There's my solution. Now I've got to graph it. Open or close circle on 1/2? Open. Where is 1/2 on the number line? Do what?
In between 1 and 2.
Not 1 and 2.
0.
Between 0 and 1. Halfway between 0 and 1, I get an open circle. Am I shading to the left or to the right here? Why to the left? Why to the right? Which one is it? It is to the left. Remember, you can only follow the rule of shading whichever way it's pointing if the variable is on the left. So if I want to follow that rule, I've got to rewrite my inequality with the variable on the left, the number on the right. Whenever you flip it, make sure the point is still with the same thing, so I need the point with the y. Make sure the mouth is still eating the same thing, so I need the mouth eating the 1/2. Does everyone now see why we're shading to the left? I want all values that are less than 1/2, so that'd be to the left of 1/2. Any questions on 1, 2, or 3 here? Feeling okay about it? Okay. Let's keep on keeping on. Same thing with subtraction. If I subtract the same number from both sides of an inequality, it produces an equivalent inequality. So -3 is less than or equal to 1 is a true statement. If I subtract 5 from both sides, I get -8 is less than or equal to -4. Is that still true? Yes, it is. Same thing over here. 7 is greater than -20. If I subtract the same number from both sides, subtract 7, I get 0 is greater than -27. Is that still true? Yes. Subtracting the same number from both sides of an inequality produces an equivalent inequality. So, some examples here. Y plus 8 is less than or equal to 5. If 8 is being added to y, what's the inverse of addition? Subtraction. So I'm going to subtract what from both sides? 8. 5 minus 8 gives me -3. Y is now by itself. There's my solution. Are there any questions, comments, confusion about anything we're doing? Open or close circle on -3? Closed. It's got that line under it. -3 is included in my solution set. Y is less than or equal to -3. Which way am I shading? To the left. Questions on example 2A? (2B). -8 is less than 1.4 plus m. -8 is less than 1.4 plus m. How would I get -8 by itself? Or, sorry, disregard what I just said. How would I get m by itself in this case? -8's already by itself. Subtract 1.4 from both sides. -8 minus 1.4 gives me negative 9.4. M's by itself, there's my solution. Where is negative 9.4 on a number line? In between negative 9 and negative 10. Not quite halfway, but almost halfway. As long as it's close, I'm okay with that. I don't expect you to get your ruler out and start measuring. Is it going to be an open or closed circle on negative 9.4?
Open.
Open, because there's no line underneath my symbol. It's not or equal to. Now, am I shading to the left or to the right of negative 9.4? To the right. Why to the right? Yeah, reading it from the variable's perspective, m is greater than negative 9.4. If you want to, you can flip it and shade whichever way the arrow's pointing. That'd be to the right. Questions on 2A or B? Still feeling all right? Can I move on to my last slide? Just 3 examples real quick. Care if I go through these pretty quick? Number 4, what would I do to get k by itself? Subtract 5 from both sides. Negative 3 minus 5. Negative 8. Boom. Open or closed circle on negative 8?
Close.
Closed, shading which way?
Left.
To the left. Questions on 4? Do I need to slow down, or am I good continuing at this pace? I'll take that as I can continue. 5/6 is less than or equal to z plus 1/6. How do I get z by itself? Subtract 1/6 from both sides. 5/6 minus 1/6 gives me what? 4/6, which reduces down to 2 over 3. Once again, if you need to, you can flip it to where the variable is on the left. That's the same thing. Open or closed circle on 2/3? Closed. So that'll be 2/3 of the way between 0 and 1. Which way am I shading? To the right. So any number that's greater than or equal to 2/3 is a solution to my inequality. Questions on 5? Okay, last example here. How do I get p by itself? P plus 0.7 is greater than negative 2/3. Subtract 0.7 from both sides. Negative 2/3 minus 0.7 gives me what? Negative 3. P is now by itself. There's my solution. Open or closed circle on negative 3? Open, shading which way? Right. Questions on 6? Give me a thumbs up, thumbs down, thumbs to the side on how we're feeling with today's lesson. Everyone give me a thumb somewhere. If we have a thumb to the side or a thumb down, do we have any questions, comments, concerns, or confusion that I can clear up. Perfect. Here's your assignment. Page 71, numbers 4 through 26 evens. It's like 12 problems, I believe. So hopefully you should be able to knock it out pretty quick. If you don't finish today in class, it'll be due Thursday the 21st on Canvas. Do we have any questions about the notes before I end the recording?